Today's question is next greater element. So basically we are given with two arrays, two integer arrays where nums1 is the subset of nums2. And what we are required to do is we are required to basically return an array that contains mapped elements of nums1 that are greater than the particular element which are present in nums2 to the right of it. Let me explain you what this means with an example provided by LeetCode itself. Nums1 is 412 and nums2 is 1342. So nums1 is subset of nums2. We are required to return an array which consists of elements which are greater next greater elements of the nums1. If no such greater element is found, we will simply put -1 in place of that particular element whose next greater element could not be found. For example, 4, there is no element greater than 4 to the right of it. So -1, 1, 3, 3 is the greatest element to the right of it, and 2, 2 is the last element of nums2. There is no element present to the right of 2, so -1, as no greater element could be found. Okay, so the complete naive solution that uh, you can think of is basically traversing nums1, locating an element, let's say 4 in nums2, then traversing to the right of the 4 and finding the greatest element. And so the time complexity of this naive approach will be n square in terms of n square. And how can we reduce this time complexity? We need to use a extra auxiliary space. And for that particular space, we will choose monotonic stack. How can a stack be useful in such case? Let's see. First of all, initialize a stack and initialize a hash map. Why hash map? We need to take account, or we need to remember what greater element belongs to which element, right? So for that particular reason, we are keeping track of elements and their greater elements in a hash map. So first of all, we will traverse our nums2 array in a reverse direction. Uh, the first element that comes is 2. Initially, the stack is empty, so this while condition is not entered, and yes, stack is empty. So we'll simply put uh, that particular element in hash map corresponding to -1 value, right? Because the next greater element of 2 is -1 because there is no such element, and hence -1. Now we will push 2 into the stack. The next iteration 4 comes. Now the stack isn't empty, and element which is 4 is, yes, it is greater than the top of the stack 2. So what we will do, we will simply pop the top of the stack, because whenever a greater element comes by the reverse iteration, which is the greatest element, then the element which is lesser than the current element cannot be the greatest element for the next iterations. So we'll simply pop those elements, and we will be keep doing this until either the stack is empty or an element is appeared greater in the which is greater and present in the stack than the current element in the iteration, right? Because if the current element because in the later iterations, if such element comes where the current element is lesser but the next element is greater, then we will mark that particular greater element into the hash map for that particular element in the next iterations, right? Now if the stack is currently empty, which means that this particular element is the greatest element which is found till now, and we will put that element in the stack, or else we will simply put that element into the hash map and push that element. So uh, this task will be performing for the all the iterations, and all our elements will be getting a particular next greater element in our hash map. So basically we are done with all the next greater elements present in our nums2 arrays. Now what we are required is next greater element of nums1 array. So we will iterate that particular array and simply get the values which are being asked for and simply return our answer array. So this was a solution which came out to be uh, optimized of linear time complexity. You can say this big of n, and the auxiliary space is also big of n. So time complexity as well as space complexity is big of n. Thank you.